for some classwork and maybe get you guys a little head start on the homework as well. All right, so today we're talking about is recursion. It says a second way of defining sequence is to assign a value of the first number and then specify the nth term by formula or equation that involves one or more terms preceding. Sequence defined this way is said to be recursively. So the idea is this, and you do this same thing, and actually we were doing it last class. And that was, hey guys, what number do we start off with? You said 2. Okay, what are we doing to get to the next one? Adding 3 every time. That's recursion. Recursion is you start off with some value, and then to get to the next one, you take that value and add something to it. So there is a little bit of differences in what we did last class and this class. You're going to see those similarities, but there's one small difference, and we'll talk about it in just a second. The biggest difference of all is how equations are written using recursion compared to how equations are written using sequences. Last class, you did sequences, and basically it was like you're just coming up with equations, and your number one variable was n. N represent what term you were on. Now, the good thing about that, and guys, let me tell you, you guys use recursion a lot, and I see it whenever you're counting with your fingers. Some of you guys aren't big fans of multiplication tables. Instead, you found ways of using, which is maybe counting by that number. So 6 times 8. Like, 6 times 8? I didn't memorize that, but I do know that's adding 6 8 times. So 6, 12, 18, 24, 30, 36, and go forth and so on. You're doing recursion. You're taking that previous value of 6, adding another 6 to it and getting 12, then adding another 6 and getting 18, 24, and that's what you're doing. You start with 1 and you work your way up. Last class, sequences, and it was this. What is the 8th term? Oh, okay, I take the equation, 6 times n, and I just plug in what term you want. Oh, you want me to go out to 11th term? That's great. 11th term is 6 times 11. So the first term is -2, and how you're going to read this is I start with -2, and then I'm going to take that -2 and subtract 7 from it every time. So, -2, -9, -16, -23, and then -30. K minus 1 tells you what term you're doing. So if I was to break this down, if I was to find the a sub 2 term, Johnny, if I was to plug it in, so that means that k is equal to 2. Plug that into this equation and you have a sub 2 equals a sub 2 minus 1 minus 7. 2 minus 1 is 1, therefore it is a sub 1. What's a sub 1? It gave it to you. So you find out, oh, okay, that's -2 minus 7, and I get that -9. Actually, it's the way the process is supposed to be done. It wasn't really checking. This is the process if I was to do it one step at a time. So if I was to go off and look at, okay, I need to now find the next one, because I got to go all the way to the 5th term, right? So a sub 3 equals a sub 3 minus 1 minus 7. That is a sub 2 minus 7. Well, what did we find out our a sub 2 is equal to? -9. That was the previous answer, right? And so you end up with now -16. Okay? So it's taking that previous answer and then adding it every time in order to do it. Next one. You're starting off with 7. What are we doing every time, guys? Multiplying by 2 and then adding 5. That's it. 2 times 7 is 14 plus 5 is 19. 2 times 19 is 38 plus 5 is 43. 2 times 43 is 68 plus 7 or plus 5 is 73. 146 or 151. And there we go. Double and add 5, double and add 5, double and add 5, right? I did tell you guys there's a calculator on this, right? Yeah. Okay. All right. Any questions about recursion? Take the previous answer and do something to it. What are we doing to it? It's whatever this equation tells you to do with it. That's it. So let me ask you guys, how would we write this? How would we write this as a sequence equation. So, what's the common difference? Is there a common difference? What is the common difference here? Well, what's the first difference? I'm sorry. What's the first one? 12, thank you. What's the next one? So this one would be what? Be careful. Right?
73.
Hmm?
How do you get 73?
Oh, that should be what? 83, shouldn't it? 93? Wow, I really missed that one, didn't I? Sorry. That was pretty bad. My fault. That's pretty bad. Yeah. And then, so, my bad. So that should be what? What'd you say this one should be down here? 48? Yeah. So 96, right? How would you write that as a common difference? We did it last class. It was one problem we did. I know you don't get it after one problem, but it's one problem we did. So the first differences weren't the same. What about going again? Yeah. Wait. Right? Is that right? Are we getting any common differences at all? We're not, are we? I mean, look how many times we've done differences there. We're down to 3, and we're still not getting a common one. There's a pattern there. However, there's not. This is just to show you guys that you can write recursion equations from sequences. You can write recursion equations from sequences. You cannot sometimes write sequence equations from recursions. This is an example right here. No, we did not do these type of equations.
Didn't you say, like, there was one where it was the same thing, and then you said, we can't do this?
Right, I made you omit it. Because we hadn't talked about it yet. Yeah, on the classwork, it was E and F. I had you omit it because we hadn't talked about it yet. But yeah, you cannot write sequence equations from recursion, because recursion is taking a previous answer and doing something to it. It's not a common difference every time, because that previous answer, guys, is always going to be different. Therefore, there's not a consistent rate of change. Okay, it's always changing in different, and it always looks weird. So it never works out that way, okay? All right, so there you go. Moving on, if I can. Whoa. Oh, okay. So let's look at these. First term is 4. What are we doing to get the next answer, guys? Multiplying by 3 and subtracting by 2. Good. So 12 minus 2. I better be careful here. Don't get me on this one. 30 minus 2. What? 84 minus 2. 246 minus 2. All right? Just take that pattern that you see in the equation and just make that your recursion. All right, so if you look at number 12 is written, it's a different way. So recursion, you can think of it 2 ways, is this. I'm on the second term. What do I do to get the second term? I go back to the first term, do something to it, and get my second term. All right, move on to the third term. Third term, go back, do something to that to get my next one, right? Or another way of doing it, and that's why you always see, guys, that's why you always see this minus 1 in the equation. Because we have to go back one term to do something to get our next one, okay? So now what we're doing is forward thinking, and that's this right here. In order to get the next term, so now I'm sitting at the term, the answer I just got. In order to get the next term, take where I'm at, double it, and add 3. So it's the same process, it's just a different way of looking at it. one point earlier, I'm sitting at the empty spot saying, what's the answer here? Oh, take what you did earlier, double it and add 7. Okay, that's what I need here. Now this equation is saying, hey, I'm standing at my last answer. What do I need to do to find the next answer? Oh, take where you're at, double it, and add 3. Do you see the difference of what I'm saying? One is more backwards thinking, because I need to take what I did and put it in the empty spot. I'm thinking of terms like this. When I'm standing around and moving around like a goofball standing up here and moving around dancing, I'm sitting at terms, okay? First, second, third, fourth. What we had been doing is we're here saying, hey, take this number to get that answer. Now the equation number 12, what we're looking at is this. I'm standing here. Hey, what is the answer for here? Oh, go back and do what you need to do and find that answer. Okay? So that's how you find. That's the difference between the two. That's why you see the +1 on the subscript or the -1. The -1 means I need to go back. That's here. Go back, do something, and come over. That's what we kind of started off today with. Yes?
So 5 would be the second number?
5 would still be, we'll look at the subscript. What is that? 1. So my first number is 5. To find, well, what's k plus 1? That means 2. To find my second term, I take the term I'm at, which is 5 right now, double it and add 3. And now I'm standing at 13. To find the next term, this one here, double 13 and add 5. Yes, you're going, Coach Esther, that's the exact same thing we've been doing already. You're right in some aspect. We are multiplying and adding, subtracting. We are doing that the same process. However, it's where we're standing at to determine where we're going to next. Am I at my last answer? Am I standing right here and seeing what I'm going to find out to get next answer? Or vice versa. Am I standing here and saying, okay, give me that last answer and do something? I know it's not a big difference, guys, but it does. When you're looking at equations, you can get confused sometimes because you're like, why does this have +1 and why does this have -1? Because this one's saying, hey, +1 means, hey, I'm standing at the answer, what I got to do next? The -1 means I'm standing at an empty spot. Give me the previous ones. Yep.
Sometimes it'll give you A2 instead of A1.
No, it'll always give you A1. It will always give you A1. Because here's the deal. So this one here says +1, right? This one says if I'm at the first term, 1, okay, what do I have to do? And if I have already know what it is, I'm standing, let's use this. K is equal to 1, let's say, okay? Well, that means A sub 1 plus 1 equals 2 times A sub 1 plus 3. What is A sub 1? 5. That works there. Same thing. 2. Well, A sub 2 says, or if K is equal to 2, it says, okay, A sub 3 is equal to 2 times A sub 2 plus 3. Well, we just found out that A sub 2 is 13. It's the idea of, it's just all about positioning. Where are you located? What answer are you trying to find? This one? Because if I'm trying to find the next answer, that's why I keep saying +1. This +1 here says I'm trying to find the next answer. Take your answer and double it and add 3. Come over here. To find this answer, go back 1, triple it, and -2. It's just all about phrasing it. So let's finish this one off. So when you get 5 terms in, we're 3 in. So what, double 29 and then add 3? Is that 58, 61? Find the last one, double 61 and add 3. 125. The process is the same, guys. You're still just taking that equation, and that's telling you what you're doing with your previous answer and going on it. It's just kind of where your point of view is. It's a difference in a point of view. Right, you kind of did a little bit of this in class for the homework assignment last class, but we're going to go ahead and work through some of these and see them kind of all together. Summation notation, guys. So you see this sigma. And sigma represents not a fraternity or sorority. It actually represents summation in mathematics. Okay? So we're taking terms. Now we've found out a way. Oh, we found out three different ways of how to write out sequences of numbers. There's using the 2n minus 3. That's what we did on day 1. There's a sub k plus 1 minus 3, which is what we just talked about this morning. There's a sub k minus 1 plus 3. So there's another one. There's two versions of it. So now we're getting a list of all these numbers. Austin, what's going on, dude? Like frantically, are you good? Okay. Everything's all right? Okay. So you have these sequence of numbers. Now the idea is, okay, I have these list of numbers out, and now we want to go ahead and add them all up. And so that's what some notation means. Which means, okay, here's an equation. I'm going to put this large summation sign in front of it to tell you that, hey, go ahead and come up with all the list of numbers, but then put plus signs in between them. So you're going to sum them all up. Now, the idea is this. That number right there tells you where you start. It's not always 1. Sometimes you can start on the third term, and you saw that on the classwork/homework last class. We had one where you started from 3 and went to 6. So it doesn't have to start at 1. This tells you how many terms you need to go in when you stop. So we look at the first one. It says summation of, starting with k is equal to 2, up to 5 of k squared. So when k is equal to 1, that is 1 squared, which gives me 1. K is equal to 2. That's 2 squared, which equals 4. K is equal to 3. 3 squared, which equals 9. K is equal to 4. 4 squared, which is 16. And we're going to 5, right? So you take what number you got to start off with. Guess what? Should I start with 1? What's underneath the summation? 2. So I'd start with 2. Oh, guess what? I just realized. Since it's IPR, next class you guys get new seating arrangements. New seating chart next week. So right before the quiz, we'll get a new seating chart. We gotta mix it up.
I thought it was every 9 weeks.
It's every 6 weeks. 9 weeks means you only move 4 times. That's not a lot.
Wait, the last
We're
time
already
we
at 12 weeks in school.
Last time we did it 6 weeks in. We didn't do it after the 9-week marking period.
Yeah, because this is only my second spot.
We did it 6 weeks in, right?
No, 9.
Yeah, no.
We did? Well, we're gonna do it again. We're gonna do it again every 6 weeks. I like to do every 6
What
weeks.
are we doing it by
Hmm?
then? What are we doing it by then?
I don't know. I gotta see what I have on my list.
So we've
Let me
already
few things. Yeah. This will be 12th. This will be the end of the 12th week. Yeah.
Wait, so we are.
We are. Yeah. When I see you guys on Tuesday, we'll be getting a new seating chart. Is it?
Because if we did it 9 weeks, now next week is 6. Oh my god.
Is this not this? Is this? This is IPR.
We've already finished 9 weeks. We've already finished 9 weeks.
Yeah, I got that because you got the report cards out, and then I'm sending out a IPR, which is 3-week progress report, which is after your 9-week marking period. So this is the 12th week.
So we moved from after 9 weeks and now we're moving.
I thought we moved it to 6 weeks. We moved it to 6 weeks. I don't think we did either, because if you moved it to 6 weeks, that means you only been in this spot for 2.5 weeks, and y'all been in this spot a lot longer than that.
Yeah, we moved at the 6.
Yeah.
Yeah, we've been here for a long
No,
while.
it's been 6 weeks.
I don't know what's going on anymore.
You are getting me, aren't you? Oh, great. I recorded my whole conversation with you guys on that. That's awesome. That's good.
What are you doing about it?
Do what?
What are you doing about it? Oh, what are we are? What are we?
I don't know. What was it? Last name, first name this time.
Can we do birthdays?
Probably. I think birthdays is up next anyways. So
Oh wait, never mind.
okay, never mind.
You're one of the older ones.
You recorded you.
You're an
Yeah, well, I record mine to put on learn. So I'll have to use my B-day lecture one of these.
up there.
Also, so,
Can we
the
do
people
like
are asking me,
so
I
nice,
want
please?
Can we do
Yeah.
favorite color?
Sit by favorite color. Okay, everybody pink, sit here. Everybody blue, sit there. 13, 29, what is that, 54?
How would you figure that out?
Alright, here's what I want you to do in your calculator, guys. On your calculator, go ahead and make sure it's reset.
I thought that was a good idea.
Mason knows. Make sure you have a calculator, make sure it's reset, please.
You can do like cars on the radio, like
Oh, really?
I'm going by your opinion. I could easily see either Kyla or Emma going like, I do like green, but Kyla likes blue, so I'm going to like blue, so I can sit next to Kyla. I could totally see that. Something you can't lie about your birthday.
Hey, can we do
No, I have your birthday right here. Huh?
So I don't sit up front.
Pardon? Oldness?
Oldest.
Oldest?
Like the younger ones up front. Like,
yeah,
because I don't want to sit up front. Because I know I'm going to have to sit over there.
You are Mason? Well, I don't go by years, I just go by the
What
month.
year? What year?
2003, July 10th.
Mine's November 18th.
Are you going by?
Okay, we're not one-upping everybody with age here, because I'll definitely lose, so we're not going to have this competition.
Yeah, you'll have to sit in the back.
I'm about to sit there. I'll sit over at like the E-wing or something. Alright.
I don't want to sit over there.
Okay, we're not going to cross that bridge just yet, okay? Alright. In your calculator, I want you to go ahead. After you reset it, I want you to press Alpha, Window, Option 2. I think some of you guys need a new partner sitting next to anyways. I think it's hurting some of you guys pretty badly.
Where's the option button?
I don't have a phone.
I know. You're going solo, William. Maybe you need a partner. We'll find you a partner. Alright, so Alpha, Window, number 2. Now the summation pops up and has everything ready for you to do. Guys, you don't always have to put the same letter that's on the problem. I always like to use X, because X is only one button away. So you can always click the X that you've always done in Y equals. That still works. So X equals, and now for this problem, you're going to say X equals 1. Press the up arrow to get to the top of the summation and put 5. And then you'll press the right arrow to get to the equation and put 4x plus 1.
It just gives you the answer.
Just gives you the answer.
What does that number mean?
But don't use I.
X says on.
Use the same letter that you used. I had you use X, so just use X.
Why was it even one?
Because it starts with 1.
Oh, okay,
Yep.
we moved on.
Yes, we moved on. Yes, we moved on.
Okay.
I know, sometimes we get bogged down.
Like, what does that number mean, though?
Which one?
54.
The answer?
Well, like,
Is that X?
I just mean, like,
This one right here.
well, yeah, I just mean, like, what does that mean to the equation?
Basically, it means if I was to take every number from 2 to 5 and square it and add them together, I get 54.
Oh.
So if this was on the test, how would we show our work for partial correction?
This would be a way to check your answer. So for you guys who aren't big fans of the multiplying or something like that, you could check your answer this way pretty easily.
How do you do 14?
14, same thing.
It's just, like, in different places. Never mind.
Right, so yeah, you'll put x equals 0, you go up to 4. Now the letter's K, but don't use, I'm just saying you can use alpha K if you want, but it's extra buttons you have to push. And some of you all are like me, minimalist, the less is the best, so if I have to press only one button instead of 2, I'm okay with that. No, minimalist. Not lazy, McKay. It's not lazy. No. We're minimalist. Yes, ma'am.
So what she was asking was like, what is a way? Like, you have to do all of that when you do it first.
You will. Right? So on the test, it'll say show all work. So you'll have to show your terms and then get your answer. And so that's what I'm looking at. This will be a way to check your answer pretty easily.
So basically on the next one, 0
Go ahead.
or k
Huh?
0, and then what you would
Yeah,
do
you
is
just do this.
0
And then
squared.
once you find your answer for this, you can check.
0 cubed.
Plus
Yes. Yeah. 0 cubed plus 2. 1 cubed plus 2. 2 cubed plus 2. 3 cubed plus 2. 4 cubed plus 2. Yes, ma'am.
So, say we do our work wrong, but since we checked with the calculator, we get the answer right.
Mm-hmm.
Are you gonna take some stuff off?
Yeah. Oh, yeah. Yeah, I'm not testing if you can type it in a calculator. I'm testing if you know what you're doing. The calculator part's just to help you check your answer on it. But hey, put in the right answer, and maybe that could help you go back and see maybe you did something wrong in the equations.
That helps me on the test.
Yeah.
When you write this, yeah, no, so this formula is only it's for the
Yeah, so how would you
yeah. So you, I don't think it's removed. I don't think it's.
So, I got you.
But then why
So,
did you
the
write
only-
8 equals 1?
5.
Yes, ma'am.
But that's just zero case number.
So this one you go
That's
7.
what you're using intrinsic we're doing this. And then whatever number you get.
So when it says calculate for each sum, you have to show your work.
Calculator, that's the
You just have to show your work.
Oh, I get it.
Do what?
When it says calculate each sum, you have to still show your work.
Yes, you have to show, at least show me the terms. Just show me the terms at least, that's all. I mean, you don't have to go elaborate and do all this right here. I'm thinking some of you guys could probably do that and that's fine, but I at least need to see your terms. And then show me the answer.
So you need to show like what k equals.
Well,
Like what we did in the last.
when k equals 0, what does that equal? When k equals 1, what does that
Yeah, so
equal?
what we did in the last
It's kind of what I did here. I do at least need to see those.
Oh, so just the right part of the top one?
Yeah.
The 2 squared equals.
You don't have to write out the equation if you don't want. I'm not really requiring that,
But
but...
the last one was an ugly fraction.
Yeah.
Wait, is there more?
Yeah. 16 is
I don't like E.
5,471 over 16.
So you guys already done 15, right?
Yeah.
So if I was to do 15, guys, this is what I'd like to see. Now this takes a little bit more work, of course. It's not just doubling and adding 3 to a number. You have to double it, then subtract it from its square. It's not very fun, so I probably have to write out an equation for this one. So it's 2, 3 minus 3 squared. What is that, 6 minus 9, so negative 3. And you got 4 times, no, 2 times 4 minus 4 squared. And you get 8 minus 16, so negative 8.
So are we working up to 5 terms, or are we only doing it to the 5th?
We're doing it up to, and it's not always the same number, Emma. It's up to that term. So it's from 3 to 6. So I'm going to go 3, 4, 5, 6, and stop. 10, 25, so what was that, 15? Negative 15. Then the last one, 12 minus 36, negative 24. And then you just got to combine all those, right? And this is the part where I'd be like, okay, here's this. Let me just put it in my calculator real quick and give me my answer. Negative 11, 26, what was that, 50? There. So, we're not big fans of fractions. Understood. It's an F word. So, let's go ahead and just do what we did before. 2 times 1 over 1 plus 2. Don't treat it as a fraction, guys. Treat it as an equation over an equation. Separate that. Still no? This has a few terms you have to do. So it's 4 over 4. I'm going to run out of room. I got to make sure I get... Do what?
So the hardest one is like the most stuff.
What did you just put?
This takes a while. Is it 6 plus 2? It is. What? That was weird. And then you add all those up. And good thing is, calculator's doing all that work. You're not doing that. I'm not doing it.
So like, I don't know if I like did it wrong, which is a possibility. But when I put it into the calculator, like the way you showed us,
Mm-hmm.
it said like 5,471 over 630.
Can you tell me that again?
5,471 over 630.
I got 28. I'm like not doing it.
It says express the sum using some notation. Use 3 as your lower limit. So this says to go ahead and it's telling you how to do your summation notation. So it says 3 as your lower limit.
So x equals 3 on the bottom.
There you go.
And then is the top 7?
And so the top, we'll see how far we need to go. In just a minute, we'll see how far we need to go. So with that, let's go ahead and create our equation. Actually, you know what? We're jumping in a little fast. Let's use this S sub 5 here, okay? I know we'll finish that. Okay, so here we go. So what is our equation here? Well, if we're starting off with 3 on the bottom, we can go ahead and make x as the numerator, right? Is the box, is it increasing by 1 every time? 3, 4, 5, 6, 7, all the way up to what number?
8.
9. We're looking at the denominator.
Oh.
We start off with 3. That's the denominator we first start off with. We increase by 1 every time up until we get to 9. So it's 3 to 9. So that's the denominator. Now we got to figure out how we get the numerator. Is the numerator increasing by the same thing every time? Does it have a common difference? That's what we talked about last class. So if that common difference is 1, that means it's 1 times x, or you can just put x. But then we got to figure out, well, that's not going to work because we don't have 3 over 3, 4 over 4, 5 over 5, 6 over 6. We don't have that. We have 2 over 3. So how do I make the top, if I'm starting with 3, how do I turn it into 2? And so there we go. Does that work every time? Is the numerator 1 less than the denominator every time? And there you go. So it's creating the equation, but you got to, on summation, is you got to realize you don't always start at 1. Sometimes, for this example, you start at 3. This is going to even make it harder instead that you start at 5. Now you got to figure out how I'm going to get 5 from all those numbers as they're going along too. So it goes on, okay, what's the notation for sum of 5? This is, guys, this is this. This is going to be a sub 1 plus a sub 2 plus all the way up to a sub 5. You guys saw that on your classwork last class. And this one means a sub n. Bless you. A sub n equals 8 plus 1, 2, all the way out to n.
So, what is A? 1, 2 over 3.
Is a sub 1 2 over 3? Yes.
That's the first.
Yes, if we're using that example. Yes. So given a sub n is equal to 3n plus 1, what is s sub 4? So, well, what's the first term? So when n equals 1, what do I get in that equation? Good. N equals 2. So then we start looking at, one more time, one last thing I got to show you guys and we'll be done. It's nothing to do with sunflowers. I want to throw that off again. That was a derail. So now we say, okay, how about if I just have an equation? Like, is there an equation I could just use? Like, yes, I have a calculator. There we go. Just put in the summation and we're done. But what if I'm given something like this? What if I'm given just the equation itself? So if I'm given the sequence equation and tells me to find the sum up to 4. So we use this equation here. The sum up to n is the number of terms divided by 2 times your first term plus your last term. Number of terms divided by 2 times the sum of your first and last term. Let's try that in this equation here. So, sum up to 4 is 4 divided by 2. Well, if I plugged in 1, which we've already done to the left side here, what is my first term? 4. Now what happens when I plug in 4 into this equation? What do I get? Now I don't have to go through, guys, and do all that work. Now I can use this formula, which will be given to you on the test and quiz. Plug everything in that needs to know, and from there I could say, okay, that is 2 times 17, which is 34. 11, 21. If I was to add all these up, guys, I would get 34 as well. So it does work.
Maybe you can just do that.
I mean, you will need to know how to do this, of course. All right. So what we'll do for class practice real quick is the last class, you had E and F that I had you omit. Go ahead and do those two real quick.